To also accommodate for the trading places of odd and even coefficients, there is also something called the conjugate QMF. That's a natural choice in which we also reverse the temporal order of the synthesis filter, even here, where L is the filter length. And then we will have that the synthesis G0 is equals to H0, but G1 is equal to minus H1. And this was introduced in 1984. For the polyphase components, this means these equations here, and we have a minus Z to the power of L divided by 2 for the H00, and a Z divided by to the power of L divided by 2 for this H1 of 0. Then the input for our determinant calculation is given here, and this corresponds exactly to the time reversed low band filter. So what we're doing here in the conjugate QMF is having this reverse of the temporal order of the synthesis filter. So now we will define the A of Z is equal to H10 Z to the power of minus 1 times H00 of Z, and the determinant now will become this here, so Z to the power of minus L divided by 2 times A of Z plus A of Z minus 1. And observe that this now can be constant if all even coefficients of A0, AZ are 0 except for the center coefficient. So remember the determinant was the output of the low band with this input. Hence, every second sample of the convolution of the low band filter with its time reversed version. And this is equal to the every second value of the autocorrelation function of the low band filter. So to the determinant is a constant or delay, only one sample of this downsampled autocorrelation function can be unequal to 0. Most even coefficients are 0. The determinant constant means that the 0th autocorrelation coefficient is a constant unequal to 0, and all other even coefficients must be 0, and this is called a Nyquist filter property. In other terms, we define P of Z as the Z transform of this autocorrelation function, and it's called the power spectrum. Then all non-zero coefficients of P of Z are the 0th coefficient and the odd coefficient, and as a result, P of Z plus P of minus Z is a constant. So the odd coefficients cancel. This is a frequency reversal, and this is also called the half-band filter property. So our design approach is to design P of Z accordingly and then move on to design H of Z.